Hello and welcome to today's Explainer. I am absolutely thrilled to guide you through this material because today we're diving into something that fundamentally shapes how you interact with the world every single waking second of your life. We're talking about your vision. But we aren't just talking about, reading the letters on a standard eye chart. Today we're exploring the really fascinating journey of vision therapy. Specifically, we're going to be focusing on Section 1, covering Chapters 1 and 2 of our source material, to see exactly how the scientific and medical community shifted from looking at the eyes as just a simple, mechanical set of muscles to understanding vision as a highly complex, cognitive brain science. It's a totally remarkable evolution, and I promise you, by the end of this, you'll never look at your eyesight the exact same way again.
So let me ask you this. It's a question that gets right to the heart of the matter. Are vision problems just the result of weak eye muscles? Well, for a really long time, both the general public and medical professionals genuinely believed the answer was absolutely yes. If an eye was turned, or if someone was dealing with severe eye strain, the immediate knee-jerk assumption was that the muscle just needed to be strengthened, or surgically moved around, kind of like adjusting the reins on a horse. But as we'll see right away in Chapter 1, this common misconception is actually completely backwards. And challenging that very idea, that's what led to a massive paradigm shift in eye care.
Okay, let's dive into this. Here's our roadmap for today. We'll be hitting 1. The mechanical eye. 2. A broader concept of vision. 3. The top-down paradigm shift. 4. Modern principles of therapy. And finally, 5. The visual processing loop. Let's get right into it.
Section 1. The mechanical eye. Let's travel all the way back to the early 19th century views to see where this all began.
You see, the roots of vision therapy stem from what was known as orthoptics, which literally translates to the straightening of visual axes. Back in the 1850s, a French ophthalmologist named Javal was incredibly frustrated with the outcomes of eye muscle surgeries. In fact, he colorfully and quite graphically referred to them as the massacres of the ocular muscles. Yikes, right? So, to avoid that massacre, he actually formulated early, non-invasive sequential steps to treat strabismus, or crossed eyes. Fast forward a bit to 1928, and an American optometrist, A.M. Skeffington, introduced a much broader concept of vision, shifting the whole field toward this really interesting mix of art, science, and philosophy. And then jumping all the way to the 1980s, we see the advent of computer-generated therapy, which was designed directly to combat the intense visual strain brought on by modern, near-centered computer workstations.
But actually, even before Skeffington, some brilliant minds were already connecting the dots. In 1912, Dr. David Wells noted something huge. He said that visual inefficiency could result in an inability to fix one's mind on studying. He actually called binocular vision an intrinsic psychic faculty. Now, in 1912 terminology, psychic faculties simply meant a cognitive or mental process. Basically, he was waving a massive red flag saying, hey, everyone, vision isn't just about eye muscles. It's deeply tied to our brain's ability to focus and process information.
And that brings us to Section 2. A broader concept of vision. Let's meet the visionaries.
These pioneers completely changed the methodology of eye training. A.M. Skeffington emphasized that patients needed to exert voluntary mental effort. You couldn't just passively sit there while a doctor did things to you, you had to actively participate. Then, in the 1940s and 50s, Fred Brock came onto the scene. Brock was an optometric giant who pioneered training in free space. And by free space, I mean out in the natural environment, rather than just staring into some bulky, rigid instrument. They realized super early on that if you train the eyes in a dark, rigid box, well, those skills don't necessarily help a child read a textbook or play catch-out in the real world. The visual skills literally had to transfer to the everyday environment.
Which paves the way for Section 3, the top-down paradigm shift.
So, the crucial point here is understanding the sheer difference between these two models. It's night and day. Simplistically, early therapies were a bottom-up perspective. These were procedures done to the patient. The eyes were viewed merely as optical systems that responded instinctively, almost like a knee-jerk reflex, completely uninfluenced by the person's mindset. But as neuroscience advanced, the field shifted to a top-down model. And this model recognizes that you, the viewer, use cognitive control. Your brain dictates what to look at, how to analyze it, and when to move your focus. Vision is directed by conscious awareness, not just optical reflexes. Ultimately, this means that you, the driver's seat.
Understanding that shift allows us to really grasp Section 4, Modern Principles of Therapy.
Let's look at the formal definition right from Chapter 1. Optometric vision therapy is defined as the art and science of developing visual abilities to achieve optimal visual performance and comfort through structured sensory motor experiences. Notice the specific words used here:
developing abilities, and sensory motor experiences. It's absolutely not about doing reps to bulk up weak muscles. It's a deep, educational, and rehabilitative process for your brain and your eyes working closely together.
So how do they actually do this? Well, optometrists essentially act as guides, creating highly specific, visually controlled conditions. They use clever tools like lenses, prisms, and filters to intentionally create a conflict between your existing visual behaviors and the specific requirements of a task. By basically making your current visual habits inadequate for the task at hand, your brain is forced to adapt. And through the process of resolving this carefully designed conflict, the patient develops new, highly efficient visual behaviors, which the text calls schema. Honestly, think of it like a software update for your brain. This is exactly how therapy successfully addresses all those complex, everyday issues like spatial awareness, visual problem solving, and motor integration.
Which leads us perfectly into our final section. Section 5, the visual processing loop. Let's move to and see how this builds into a continuous cycle. Step 1 starts at the eye. This is where there is sensory coding of the light distribution hitting your retina. Then, step 2 happens in the brain. This is the central processing unit where your conscious decisions for selective attention are actually made. And finally, step 3 is the motor outflow, where the brain sends signals right back down to orchestrate the precise eye movements and focusing adjustments needed. It's a totally continuous dynamic cycle.
And this brilliantly illustrates exactly what we just discussed, pulled straight from Chapter 2 of the text principles. This model really simplifies the vast complexity of the visual system. You can clearly see the arrows forming that constant feedback loop. The sensory input from the eye goes to the central control in the brain. The brain makes conscious decisions, sends signals to the motor cortex, which then physically moves the eyes, generating entirely new sensory input. The whole system is continually monitoring sensory input to check if its motor responses are actually accurate. And if there's a deficiency in any one of these 3 basic areas, well, that can result in overall visual dysfunction.
Out of all the concepts we've explored today across Section 1, this specific clinical pearl from the text is the one thing I really want you to take away. Quote, "Vision is a dynamic, adaptive process influenced by environmental conditions that can be modified through therapy." End quote. You are not simply stuck with the visual habits you currently have. Because your visual system is actively driven by top-down cognitive processes, it possesses an absolutely incredible capacity to learn, to adapt, and to improve when given the right structured experiences. Honestly, it's incredibly empowering stuff.
We began our explainer today by looking all the way back to the 1850s, but I want to end by looking forward. As the text noted, the rise of computers created entirely new visual demands, and today, our world is more digital, more socially isolating, and way more near-centered than ever before. So if vision is heavily influenced by our environment, then as our screens get closer and our daily usage goes up, how will vision therapy need to evolve next to keep our visual systems healthy? It's a fascinating question, and one that highlights just how critical this ever-evolving science truly is. Thank you so much for joining me on this explainer today, and keep an eye out for our next deep dive.